In this problem, we know the following. We know the mass of A equals 7 kilos and is attached to the block X with the help of the rope which passes over a pulley. Then it says a 60 Newton force is applied horizontally to block A, which is shown right here. And then keep it in contact with a rough vertical face. The coefficients of static and kinetic friction are mu sub s equals 0.40 and mu sub k equals 0.30. Static and kinetic. Then it says the pulley is light and frictionless. Another keyword. Then it says the mass of block X is set so that the block of A is on the verge of slipping upward. So what we're trying to find is the mass of block X being closest to one of these values. So the first thing we do is draw the situation, and we have the box right here. The box has a tension going upwards and normal force going towards it from the left to the right. Then we have another force going to the left, which is 60 newtons. And then we have the friction going downwards, or not downwards, but to the left side. And then we also have the weight going down. So next we're gonna do the sum of the forces on the x direction and the y direction. On the x direction, we have the following. We have n minus 60 equals 0. In regards with the sum of the forces of the y direction, we have t minus friction minus the weight. Why is it minus? Because it's going downwards, both of them. And that's going to be equals to m times the acceleration of y, which is the same as 0. Next, we just try to solve for t. So we put mu s times n plus mass times gravity. Then we just give it some values to n, mass, gravity, and we also have the value for m sub s, which is 0.4. And that should give us the value of t, 94 newtons. So to find the mass of block X, we have to draw the situation. We have the block X right here, we have the tension going upwards, and we have the weight going downwards. So in this case, we're gonna do the sum of the forces in the y direction, and that's going to be equal to 0. Therefore, we could say that tension is equal of the mass of the block X times the gravity. But we calculated first that the tension is going to be 94 newtons. And as we bring down the gravity to the bottom, it's going to be 94 newtons divided by 10, and that should give us the mass of X. Therefore, we divide and we end up getting 9.4 kilos for the mass.